Why? Jedi must craft their own lightsabers to connect with their tools. Though I'll never be a Jedi, in my office world, the keyboard and mouse are my trusty lightsabers.
With these formidable tools at my command, I shall vanquish the relentless emails and spreadsheets that dare to cross my path.
Criteria. I like compact keyboards. They leave more room for the mouse and are easy to carry in a bag. But just like ultrabooks, they lack the numeric keypad. After some research, I found keyboard that could meet these criteria, the 96 or 1800 layouts. It's not easy to find one with European layout, meaning an L-shaped enter key, and it's even harder to find slim ones since thickness is crucial for me as I intend to carry it in my bag daily. A mechanical keyboard is at least 3.5 cm thick, mainly due to the use of switches that are tall, 2 cm compared to about 1 for the so-called low profile. I searched for a 96 or 1800 circuit board with the European layout and compatible with low profile keys. Result: nothing. Making your own circuit board is doable but difficult. However, there's a solution: you can completely skip it. You just need to solder each key with diodes and wires straight to the microcontroller. Layout. First, some observations. There's a lot of waste in our layouts inherited from very old systems. For example, the numlock key comes from the IBM PC XT, which didn't have arrow keys but only number keypad. On a keyboard with a number keypad, this makes no sense. The scroll lock key and the break key, designed 50 years ago to stop scrolling in a console, are no longer useful. The exponent key, which is well placed on a French keyboard, serves no purpose at all. I've used machines other than PCs, and the approach was new, especially for the number keypad. For instance, the Atari ST was ideal for programming, with parentheses on the number keypad and easily accessible brackets similar to QWERTY layout. This brings up the question of usage. Do I type more in French or do I need to program? I have a hybrid usage, so what symbols are the most frequently used in the text that I type? Statistics study. I created a Python script to perform some statistics. Here are the results obtained from a few representative texts. I focused on symbols, but included some regular characters for reference. Not surprisingly, parentheses are very useful even beyond computer development. On an AZERTY keyboard, many symbols are placed without any logic. I asked my old friend, who have been using AZERTY for over 35 years, and we all face the same issue. We have to glance at the keyboard to type brackets, braces, and even the common @ symbol. A layout editor. Keyboard customization has become a hobby for a whole community, and so there are great tools like Keyboard Layout Editor. With this, I can create a layout that meets all my criteria, and here is the result. 116 keys in a small format thanks to the addition of a 7th row of keys. A number keypad that features parentheses as seen on Atari and Amiga, an undo key like on an Atari, the del key near the arrow keys and other navigation keys. Brackets and parentheses are on 2 adjacent keys like on a QWERTY, and the exponent key replaced by @ symbol similar to certain Mac keyboards. Component selection. Switches. My preferred switches for their quietness and pleasant feel are the red Keycaps V1. They are linear without a tactile click. However, I will also use some clicky switches for function keys. As for the macro keys, they will be completely different. Much shorter and harder to avoid accidental presses, I will use tactile micro switches, available in various shapes and sizes, commonly used in household electronics and automotive applications. They are very affordable and produce a noticeable click when pressed. Keycaps. There are much fewer options for low-profile switches, and in any case, if I want to create a unique layout, I'll have to make my own key legends. Microcontroller. I also need a controller that will be the brain of the keyboard. I've chosen the latest one, the raspberrypipico, not to be confused with other Raspberry Pi models, which are full-fledged computers with an operating system. As for the rest, diodes, a USB-C connector, some wires and solder are all very affordable. The chassis that will hold the switches will be 3D printed, allowing for great precision and complete freedom. 3D modeling. This project gave me the opportunity to learn Fusion 360, which is free for personal use. 3D modeling is not simple. It requires a certain meticulous mindset and a whole lot of patience. There are both wrong and right way to work on it, and unfortunately, we often discover the right approach after some trials and error. What worked for me was importing the two-dimensional drawing generated on the web using the layout with web-based tools. I then meticulously redrew it, added some layers, and specified the correct thickness to generate a 3D model. There are many little details to work on, especially for designing the macro key from scratch. I added an intermediate layer with channels to guide the wires that will connect all the keys. There's a slot for the USB connector and holes to accommodate nuts that will be used to screw on a metal plate. Since my 3D printer has 30 cm format and my keyboard is 36, I cut the piece and print it in two parts, which I later glue together. Soldering. As I have 116 switches and 26 GPIO pins on the controller, I need to use a connection matrix with 18 columns by 7 rows. This will use just 25 GPIO pins. To allow simultaneous multiple key presses, I need to add diodes to each switch, which means a lot of soldering. I use the diodes themselves to form the rows, so I had to use insulated wires for the columns. This type of enameled wires is perfect, because you can heat at 400 degrees the parts you want to make conductive and solder the rest at 250 degrees. Using a multimeter in conductivity test mode is essential to check the work as you go along. Well, in hindsight, I can tell you that I had to reduce several solder joints once everything was done. Software. I use a firmware called Keycaps, created in CircuitPython. It's really easy compared to doing everything from scratch. This firmware allows for quick implementation of any layout and even enables multiple keyboard layers that can be activated with keys like Alt or any others. It's even possible to use arbitrary key combinations. The steel plate. PLA from the 3D printer is good, but it's quite fragile and too light. I ordered a steel plate from a specialized website with a custom fold at the right spot. They can also do custom drilling, and I highly recommend it because we need a precision of 0.3 mm for the small screws. The right thickness for my project is 1.5 mm, which add 585 grams to my keyboard. A 2 mm plate would add 733 grams to the 350 grams of my keyboard. Since it's a portable keyboard, I found that 935 grams was already heavy, and once placed on my desk, nothing moves. It cost me a little over 30 euros per plate, and I made two versions. Keycaps. For the keycaps, I started with a cheap AZERTY keycap set, to which I first added vinyl stickers. They were printed using an inkjet printer, resulting in visually good quality, but the touch felt unpleasant as they were very sticky. I used a keyboard like this for a week to ensure it was the right layout for me. During that time, I made some adjustments, getting closer to the standard AZERTY for the accents. To finalize the result, I spray painted the keycaps with vintage colors that I liked. Then I applied varnish and placed decals, also printed with my inkjet printer. The result is very precise, but I had to add varnish on top to protect them, making the keycaps shiny with a slightly slippery touch. Conclusion: I use this keyboard every day at work, and during this project I've gained many skills in 3D modeling, 3D printing, microcontroller programming, vinyl stickers and even decals. The overall experience has been very positive, even though it took me much more time than anticipated and cost me over 150 euros in parts. Above all, I have the satisfaction of owning a truly unique object that I love and use daily. Difficulties. I encountered difficulties with designing custom keycaps and key housings, as well as with the Keil shock stabilizers, as they are poorly documented. Likewise, having a debug console is also a good idea. I hope you enjoyed this video and perhaps even found it inspiring. Until next time, see you soon!